Good afternoon, everyone, and welcome to today's fabulous webinar where we're going to experience the Makerbot method live. Very excited to have with us today Adam Liederfarb and Philippe Castaneda from Makerbot to not only give us a little bit of an overview and some more insight about this printer, but also, as you can see in the background through live streaming video, there's the method itself. This printer is pretty badass. And it is the first what's called a performance 3D printer, which is bridging the gap between having an industrial type 3D printer and a desktop 3D printer with the new technologies being used within the method. I'm going to let Adam and Philippe talk more about that. So Adam has been with Makerbot. He's a sales director with Makerbot, and he's been with Makerbot 7 years. So he's seen a lot, and he's done a lot with that company as they've grown. And Felipe has been with Makerbot for 3 years as their senior creative manager. So I'm very excited to have both of you guys on today. Thanks for being with us.
Thank you. You're welcome. Thanks for having us.
Absolutely. So before we roll into your presentation, we just want to get a feel for the audience. So just a quick poll: do you currently own a 3D printer? And if you don't, there's no shame in that. Just trying to get a feel for the audience. All right. 2 more painless questions. The next question is, how often are you outsourcing 3D printing? How often do you or your company outsource for 3D printing needs? Even if you have your own 3D printer and you're still outsourcing for some kind of specialty need, that still counts. Couple more votes coming in. Okay, last question. How can 3D printing help your business? Or this could be, how does 3D printing help your business if you already have a 3D printer? And there's more than one answer that you can select. So if there's multiple answers, you can select them. So while you guys are voting, I'm going to let you know everyone's going to be on mute during the webinar and the presentations. We hope to finish everything up by 1:30. We will have a question and answer session at that time. If you have any questions, feel free to type those into the dashboard in the questions box beforehand or at any time. We'll try to answer them during the presentation, but we will definitely answer all questions at the end. The other thing is, as you can see, there's a streaming video of Adam and Philippe and the Makerbot method. So if you want to make whatever larger or smaller, you can just toggle the bar that's in between the two and make it larger or make it smaller. For some people, it might be side to side. For me, it's top to bottom. So with that, you guys have control. Thanks again for leading this webinar today, Adam and Philippe, and let's do it.
Thanks a lot, Robert. We appreciate it. And yeah, to reiterate, just to introduce myself quickly, my name's Adam. I've been with Makerbot for almost on 7 years in October. And I am our sales director, so I manage our sales team here, and I'll let Felipe.
Right, my name is Felipe. I'm turning on three years this year, managing the creative team. So basically parts of the printer, and then also how do we go to market with it, with marketing initiatives.
Okay. Give me 1 second here. So what we want to walk you guys through today, we want to introduce Method, introduce the product that's sitting behind us. It's a new offering for Makerbot, and it's only been shipping since March, so it's fairly new to the market. We want to take you through a little bit how we arrived at this new product, what were some of the choices we made to kind of produce Method, and then talk through what are some of the key differentiators and features that make Method kind of what we're calling a new category of performance 3D printing. We'll walk you through those features, and then we'll talk more about the offering. How do we offer Method into the market, and what kind of comes with it? Then we'll open it up to a Q&A at the end, where we have some questions we'll be able to answer for you. We'll show you some parts, and obviously you can see the printer here behind you. So let's get started. So a quick kind of a brief history on Makerbot, and this will kind of help give a better understanding of where we arrived with Method. So currently Makerbot is the #1 3D printer in the education space. So we're in over 6,000 schools currently, and that's mainly due to our desktop 3D printing line. So we have a printer called the Replicator Plus. That printer, due to its accessibility, ease of use, the materials and content we built around it for the education space, became very popular in K through 12 education and higher ed. And it was one of the leaders of the desktop 3D printing movement. So with that, obviously a lot of other desktop 3D printers kind of came up on the scene. So ones you might have heard of, like Ultimaker, XYZ, Lulzbot, they're all kind of born out of that hobbyist DNA. Very accessible, very experimental, but all kind of on that same FDM, desktop additive manufacturing format. And then if you're familiar with 3D printing, on the other side of the house, you have your industrial 3D printers. So Makerbot's actually a subsidiary of Stratasys. They're the largest industrial 3D printing company, and they build industrial 3D printers. So these printers are known for their precision, their reliability, but because they're industrial, they're also inaccessible from a price point standpoint and from a usability standpoint. So we knew that there was a technology barrier in the space. So our answer to that was Method. So Method's the printer you see behind you, and we call this segment, that barrier, the first performance 3D printing category, and this is our first performance 3D printer. And we are kind of, our tagline is that and Robert mentioned it before, is that we're bridging the gap between a desktop 3D printer and an industrial 3D printer. So kind of what defines performance 3D printing? There's 3 pillars that we've kind of used to define this new category. The first is industrial reliability and precision. The second is fastest CAD to part. And the third is price to performance, so maximum innovation for a minimum investment. And I'll kind of dig into what those specifically mean here. So in terms of industrial reliability and precision, what that means for Method is that on this printer, we're guaranteeing dimensional accuracy and repeatability within plus or minus 0.2 millimeters. So we're offering 0.2 millimeter dimensional accuracy. So this, to give you an idea, this is something that's only been achievable on the industrial 3D printers to date. And obviously, having that the ability to print with those types of tolerances has been something that you'd have to invest at least $30,000 and above to be able to achieve that. We're bringing it down in performance 3D printing with Method. The second is fastest CAD to part. So Method is actually going to be 2 times faster than the leading desktop 3D printer. So in terms of the print speed itself, it's going to be 2 times faster, but the entire workflow in terms of that accessibility, what Makerbot was kind of known for in the desktop 3D printing space, the software Makerbot Print, being able to easily take your STL and OBJ file, bring it into our easy-to-use software, send it to the printer, and print it. And then also on the post-processing or post-production side. So we use water-soluble supports, which we'll talk a little bit more about in a bit. But everything is meant to be extremely quick, fast, and easy. And again, about 2 times faster than anything on the desktop 3D printing market. And the third, and I think the most exciting, is the price to performance. So the method is coming in at about 1/3 of the cost of the entry-level industrial 3D printer. So again, you're getting those industrial properties for 1/3 of the cost. So it really kind of fits not only a technology gap, but also a price gap in the current additive manufacturing landscape. So I'll pass it over to Felipe to kind of talk through some of the actual features that make those 3 pillars possible.
Right. So as Adam mentioned, there's a few things that we want to deliver with the machine, and the way that we do it is through specific features that come with it that are traditionally associated or only accessible to high-level industrial systems, starting with the circulating heated chamber. That basically means that unlike other desktop systems, we heat up the whole print environment, not just the build plate. Many of you might be familiar with heated build plates. That guarantees dimensional accuracy and better layer addition for the first couple of layers. But once you start to go away from that first set of layers, you really need to be able to control the whole environment where you're printing, because as the build plate separates from the extruders, you will have some warping issues if you're not controlling the whole setting, which is what we do with Method. The heated chamber actually goes all the way up to 40 degrees C, which keeps the plastic warm and happy, and allows it to cool down at a much more even rate, so it doesn't warp, it doesn't want to contract as you're printing, and that helps a lot with guaranteeing that dimensional accuracy that Adam was describing before. Second big feature is going to be our extruders. We call them performance extruders. I have here, for those of you seeing the webcam, kind of an example of what a desktop printer offers as an extruder and what the Method extruders look like. Just at a glance, you can see that the extruder is much bigger, and there's a reason for that. It's not just the size, but the fact that it includes a whole suite of sensors and also a gearbox inside that will help drive the filament at a much more even pace, at a much more controlled pace, and also will help with detecting any sort of issues with the filament flow. Not only that, but it also allows the filament to warm up way faster, and the actual heating element is 3 times as long, which actually helps to prepare the filament in a better way when you're printing. So it's quite a few set of sensors, mechanisms, and ultimately supporting technologies that allow you to better control the flow of the plastic into the part, and that immediately translates to better results when printing your parts, right? Being able to properly describe the geometries of your part. As an example, we've run a few tests here. You can see kind of like the 2 samples here trying to push a bearing into the same part. We printed the part on the left in a competitor's printer and the part on the right on a Method printer. The important thing, we all know that press fits on the bearings might be better ultimately for the performance of it. However, the goal here was whether or not we could respect the actual dimension of the bearing when printing it out of the machine. So it was 80 millimeters. We didn't change that spec. We didn't give any tolerance. And in one of them, the bearing actually fits nicely and snug. On the other one, it just doesn't. And the reason for that is because the printer is not able to actually control its movements, especially once you try to move both axes as one at the same time as you're describing a circle. You're moving in both the X and the Y axis. That's going to be harder to control, in any system. But in Method, it's actually because of the robustness of the printer, because of how stiff it is, and the control of the plastic that I was describing before, you're actually able to deliver on those tolerances and be able to, the goal here was to allow engineers and designers to trust the dimensions in CAD and not have to design for 3D printers. We hear often out in the market that people will actually have to adjust their dimensions just to, take into account the tolerances that the printer might have. Here with Method, we are delivering the actual dimensions that you're putting in the CAD so that you don't have to think a second time or redesign your parts before printing them out. The second video here is going to be showing another sample part that we have here. This is a nice set of cubes, fit cubes. Basically, they have an offset of 15 microns each, and they need to do two things very well. They need to respect the dimensions of the part, and at the same time, they need to print very straight lines very accurately. And what happens with many desktop systems is that you'll get a little bit of excess material because of that lack of control in the flow rate that kind of damages the corner of the cubes and prevents them from actually locking together properly, as you can see in the animation there, right? In one of them, the method one, it just slides properly in place. And the second one is just impossible because of the fact that, well, the tolerances are not quite there. The plastic has not been properly controlled, and the corners are not real corners. They're kind of bulging out. So ultimately, it comes down to poor part quality and you not being able to actually fit your parts together, especially for assemblies. Third one would be, as Adam was saying, our soluble supports. This is actually PVA. PVA, it's very similar to Elmer's glue. So it will dissolve in water. That's the way that the part that Adam is holding right now, a set of goggles, skiing goggles. Once you put that part in water, the PVA will simply dissolve. And for example, here we have kind of the two parts. We call this the maze cube. The first one with PVA, the second one without. You know, you leave the part on water for about 4 or 5 hours, and the PVA will just dissolve, which is great because many of us, you know, designers, engineers are printing fairly complex parts with overhangs, with very intricate geometries that need supports to actually be printed. And if you're not printing with something that can be easily removed, well, it's going to be tricky for you to actually use the part as intended.
Yeah, and I think the key thing here is this is water soluble, so you don't need any kind of chemical solution. You don't need any kind of special bath or any kind of materials that you wouldn't be able to have in an office setting, or even sometimes in a manufacturing setting. So you just literally dump this in a bucket of water. Some agitation might speed up that 4-hour time frame, on this piece. But yep, H2O, this dissolves. It allows you to print unlimited or unrestricted geometries like this.
And you see another example here. It's actually a gripper that we developed in-house. It prints in a single go. So all of the parts are print in place, what we call print in place assemblies. And once you dissolve the PVA, the claw simply works for you. I think we can skip that one for now.
I saw that gripper at the Rapid show. I thought it was quite impressive. It's a very impressive piece.
Yeah, it's quite cool, especially because of the fact you're combining many of the best attributes of the printer, right? The PVA, the tolerances, because you're actually nesting parts one inside of the other, the cylindricity, being able to respect all of the pegs and all of the dimensions of the gears so that they actually work. And when you try to do that with other systems, it's just impossible because the plastic will fuse. You don't have the proper management of the PVA. You're not able to actually control the warping of the part.
Yep.
So yeah. Moving into kind of the insides of the machine. The machine is not, as you can see, it's very different from a desktop system. It uses a proper rigid structure, what we call the rigid metal frame. And that means a couple of aluminum extrusions on the sides and a solid gantry on the top and a cast base, right? That means that your printer is not going to be rattling around, especially as we said before, as the extruders move along, they will want to flex the printer a little bit, and that flex, even though it's hard to see or you won't see it immediately in desktop printers, but it will be reflected on your parts. It will mean that your parts have a little bit of an excess tolerance that needs to be accounted for because of the fact that the printer is flexing just slightly. And with Method, we've actually solved that by creating a very sturdy structure that keeps the extruders in the place that they need to be, guarantees that the printer knows where in space is it actually putting the filament and the plastic, and ultimately yields better parts for you. We also have the precision materials that come with the machine. They come here in the 2 material base. Right now, we are supporting 3 main materials. It's PETG, PLA, and our tough material. Depending on your application, right, there's a range of options for you to use, and they have all been tested thoroughly with the system. We actually guarantee that they will work and they will deliver you the parts that you're trying to print with them. And then, as I was saying, the first material that I mentioned was PETG. We just introduced PETG about 2 months ago, or in Rapid, I don't remember, about 2 months ago. PETG is a great material for engineers to use because it has a better tolerance for certain chemicals. It also, it's tougher than ABS in many ways. So it's great for you to prototype actual functional prototypes. It's great for you to prototype certain jigs and fixtures that require a little bit more strength on the parts. And we're now offering it, which, it's a material that's actually better suited for only industrial systems. You can see some of the desktop systems trying to use it, but if you're not actually controlling the print environment, if you don't have a heated chamber, it's going to be hard for you to actually print with PETG appropriately. So, yeah.
And then one thing I'll add to that is Method is, a new platform for us, and we're calling these precision materials because we've done a significant amount of testing on the materials to be able to deliver on those pillars that we mentioned before, so the plus or minus 0.2 millimeter dimensional accuracy. So while we have these materials now, we're obviously developing further other materials as we work through this, but we won't release anything until we're able to match that dimensional accuracy and those pillars that the performance 3D printing is known for.
Doubling down here on the price for the materials, as you can see, it's way cheaper than most of the industrial system. The F series, the U-Print, Onyx, and Mark II, way more expensive. So that also means that you're able to print without thinking about how expensive is my part going to be. You're just able to keep using or getting your ideas out, getting your concepts out the door, and not have to consider the additional cost of running the machine, right? So it's not only the initial investment, as Adam was saying, industrial printers that start at $20,000, $30,000, but also the ongoing costs of materials that we all tend to think about as you're using these machines. As I said before, the spools are not only better because of the fact that we test them a lot, but they're also better in the way that we actually manage them. In many desktop systems, you'll have the spools hanging on the side or ultimately exposed to the environment. And with Method, we actually have proper airtight seal base. What that means is that we are able to control the level of humidity in your spools, and that also means that you'll have better parts because of the fact that many of these plastics, as we all know, are sensitive to humidity. They'll be soaking up humidity, and that will actually damage the way that your parts is being printed because it creates micro bubbles in the filament that as you run it through the extruder, they'll explode and basically compromise your part. It's important in most of the filaments, on the material filaments, but in PVA, as I said before, PVA is the material that we use as support. It's a water-sensitive material. If you're not actually enclosing that material properly, you will run into issues very fast. And there's many desktop systems that we've tested out here that offer PVA as a support material, but because of the fact that they keep it outside, the PVA is just soaking up the humidity from the office environment, and that's enough for you to get a damaged spool that will ultimately yield poor results. Finally, our great 5-inch display. It's our design team has created an awesome set of features here that actually help you with the print, help you with managing the printer itself. Super intuitive. The goal was to replicate the ease of use of our Replicator Plus, and then some, right? We wanted to deliver something that was super intuitive, super easy to use, that wouldn't require a technician to run, that any engineer or designer in your office or studio would be able to approach and simply run prints with. And I think we've accomplished that with our UI here in Method. And the print software, right? How do you slice your parts and prepare them for the printer? It's as easy to use as before. We run it through our custom Makerbot print software, where you can select the type of material that you will be using, the type of settings. We developed a few of them already for professionals, starting with our solid setting. As you can see here, here's like one simple jig that we printed here. This is kind of with our balance mode. Now with our solid mode, I don't know if you can hear the difference there, but the point is that you're able to create almost entirely solid parts that actually will yield better performance because of the fact that they're super robust and better suited for certain applications.
And then one thing to add about our software, it's a free download off our website. Mm-hmm. So even if you wanted to go and poke around in it right now, you could just go to makerbot.com, download it. It's called Makerbot Print. start bringing your STL files. You can slice them. You can see how long it would take to print, roughly how much filament you would use in whatever setting you give it. And I think it's pretty straightforward. So I definitely recommend doing that if you're considering moving forward with it.
So overall, what Method offers is materials control, right? We are able to actually control both where the materials are stored and how the materials are printed. The environment control, as we said, with the heated chamber. The accessibility features that come usually with desktop systems are also covered here, and that's usually not as not included with industrial systems. You do need to have a technician to run these machines because they are fairly complex. And finally, the total cost of ownership, right? It's not only the fact that it's quite a few features included in a small package, but also the fact that it's really priced at a very competitive level for anybody to use.
And on that note, I just want to give a brief overview of how we kind of offer this printer. So we obviously sell the printer itself, and we sell through 3HDI, who's one of our strategic partners. But we also packaged Method in an offering called Method for Business, and we built this offering, Method for Business, to basically address the risk sensitivity of customers who are investing in any emerging technology, but specifically something like additive manufacturing. We realized that at this price point, we're going to get a lot of new early adopters. So we wanted to make sure that we were basically making sure it was more or less a risk-free option for them. So Method for Business includes something called MakerCare Platinum, which is our most comprehensive service and support plan. So our service and support is done in-house here in Brooklyn, probably about 50 feet away from us right now. And we offer phone, email support within hours if you have any sort of issue. But what Method for Business gives you, it gives you 3 years of that risk-free service, which includes 6-hour business response time at the maximum, but it also gives our customers unlimited hot swap option, which means if you troubleshoot with one of our support staff and they're not able to fix your issue over the phone with you, they will actually swap a new printer or ship expedited new printer out to you right away. So basically it eliminates any sort of downtime you might have. I know if you're investing in this technology, you're usually doing it for some sort of project, whether you have one or many of these. Any downtime could put a dent in your ROI or whatever type of project you have. So we want to make sure that you don't have to deal with that. 3 years, unlimited hot swaps. And again, it's designed to make that additive workflow rock solid, especially if it's new or an existing workflow you have. So that is it in terms of the slides. We'd love to open it up to Q&A. I know Robert might have some questions, and we'd love to chat.
Absolutely. Feel free to type your questions into the dashboard. One question that did come in was you had mentioned earlier about the Lowsbot system. How does the Method compare to the Ultimaker 3D printers?
Right.
Yeah, go ahead.
I can start with it.
Yeah.
So actually, the extruder that I was showing you guys before, this small one here, it's actually an Ultimaker extruder. It's a very simple system that allows you to sort of get your hands under the hood if you wanted to. What we wanted to offer, especially for professionals, is it's a system that's robust enough that does the work for you, right? We don't want something and you will have to be servicing a lot. Ultimaker only offers the heated build plate. As I mentioned before, that's good for the first couple of layers, but once you start to get away of that build plate, once the build plate starts to retract as your part is being printed, you will lose the benefits of the heated build plate, because ultimately you need to control the layer that you're printing at, not the first couple of layers. And the final element is going to be the actual material management. As I said before, in Ultimakers, you have the tools exposed. That means that they are going to be compromised by humidity. Specifically, Ultimaker also uses PVA, and we've seen it quite a bit. The PVA will start soaking humidity from the environment, and after a few weeks, just having the printer running, it'll start causing issues because of the fact that, as I said, it'll absorb water, and once the filament runs through the extruder, is heated up, that water actually bubbles up and just bursts. You can hear the hissing sound or the popping sound coming from the extruder. So it's back to those three main issues, right? It's how do you control your print environment, how do you control your materials, and ultimately how do you deliver a proper dimension and proper part for your users.
And I think Ultimaker, kind of going back to what I was speaking about at the beginning, Ultimaker is again kind of born out of that desktop 3D printer movement, much like some of our other desktop 3D printers like the Replicator Plus. It has the open printing environment. It does have a heated bed, but the big differentiator here, and something that is only really available on industrial 3D printers, or have been to date, is the heated chamber, right? So we're controlling the entire printing environment as it's going, building up your print, whereas a desktop open air printer will only secure kind of those bottommost layers, and then you lose that control, which that's going to make you able to print with these types of tolerance versus kind of losing it, dealing with warping and things like that.
Yeah, controlling the build chamber is definitely a big plus in maintaining accuracy and consistency from one part to the other, which is why you can print gears and have them intermesh and they run smoothly instead of, jagged or not at all.
Yeah.
Another question is, after the part is being dissolved in water, as far as the water soluble solutions, what's the disposal process? Is there any special disposal process with that?
No, that's actually one of the great things about PVA. You don't have to manage the water. With many of the industrial systems, because of the type of chemicals that you'll use to dissolve the supports, you cannot just send that water back into the drain. You have to actually run it through a proper chemical management or treatment facility. In this case, with PVA, you can just dump the water back into the drain and it's completely safe.
So. Yeah, as you mentioned, the finish after you dissolve it kind of looks and feels like Elmer's glue, and then it's fine to put down the drain.
Good deal. One more question that's in the queue right now is, what are some other materials you are looking to develop in the near future for this printer?
That's a great question.
Yeah, I mean, as much as we can talk about, some of the ones that we're looking at are nylons. Again, I think going back to what I was saying, the most important thing for us, and what the core use of this printer is going to be that consistency, that reliability, and obviously bridging it with the accessibility. We won't come to market with something unless we're able to match that. So nylons are something we've talked about, and more to come on that kind of stuff. PETG was something that we had been working on and came out post-launch, so came out after launch, and obviously that's our big. We know that there's a need for more materials, so
and it's actually super exciting because usually when we hear the question, it's great because we actually have a roadmap of materials that are going to be coming to market. As we said, only about 2 months after the printer started shipping, we actually introduced a new material, and that's kind of the cadence that we want to follow, to keep adding materials to the suite of the options that you can have the printer with. So it's exciting, at least for me. It's great to know that it's a product that you're getting and will keep growing as you keep using it. So more options are coming, and we're working on them right now, actually upstairs, testing the new ones that are coming down the line.
Cool. That's exciting stuff. Well, gentlemen, thank you for your time, and thanks for being on today. I also like to thank our audience for being on. If you have any questions or need to get in contact with me to learn more about the Makerbot or get any information, just respond to any of the emails that you received regarding this webinar. They come directly to me. I will send everybody a copy of the recording, a link. This will be posted up on YouTube. So thanks again, everybody, for joining, and have a great afternoon. Take care, everyone.
Thanks for having us. Appreciate it.
Cheers.